solution. You see, solve the linear programming problem, maximize z equal to minus x1 minus x2 such that 3x1 plus twice x2 greater than or equal to 30 and minus twice x1 plus 3x2 less than or equal to minus 30, x1 plus x2 less than or equal to 5, x1 comma x2 greater than or equal to 0. So here you see this actually here suppose this problem is given, not mentioned, this, it has no feasible solution, just given solve the linear programming problem. Okay, so after the final simplex table we can say that whether this gives a feasible solution or no feasible solution like this. Okay, so for solving this, first you check here the problem of maximization, right? So it's okay because if minimization, then we convert it into the maximization. Next one you see here, constraint inequality is what, right? So if constraint inequality, before saying constraint inequality, first you check whether right hand side of the constraint is positive or negative, means constant part. Suppose first constraint, right hand side is what? 30. So 30 is what? Positive. For the second constraint you see less than or equal to 30. So this is negative, right? And next third constraint is x1 plus x2 less than or equal to 5. So for using simplex method, first one is you see objective function is maximization or minimization. If maximization, no problem. If minimization, then you convert it into the maximization. Second, what we do, constraint sign, this constraint constant term should be positive, right? So here second constraint is constant part is negative, so we multiply both sides by -1 and then make it into the positive, right? So when we multiply both sides of the second constraint by -1, then what happens? Then minus twice x1 will be plus twice x1, then minus 3x2 greater than or equal to 30. Okay, so here you see first constraint inequality sign is greater than or equal to, second constraint after multiplying this is greater than or equal to, and third constraint this is less than or equal to, right? So if constraint contains greater than or equal to symbol, then which variable we use? Slack or surplus? Greater than or equal to symbol is present, then we use which variable? We use here surplus variable, right? So surplus variable, what we use here? Minus, here this is minus x3. So in the solution part written, multiplying the second constraint by -1 and within bracket to make the right hand side positive and adding slack and surplus variable of the given problem reduces to the form. So first constraint will be what? 3x1 plus twice x2 and this is minus x3, right, equal to 30, right? Then twice x1 minus 3x2, then again you use here this is surplus variable, then minus x4, right? And then x1 plus x2 less than or equal to 5, then you use here slack variable. Slack variable is I5, right? So here when you use surplus variable, then immediately you use here also artificial variable. Also you use the artificial variable, right? So here artificial variable, what you use, then you see in order, why you use the artificial variable? For getting the identity matrix, right? So here two artificial variable we use. This is x6 and x7 in the first two constraint, right? And large negative price factor minus m to the artificial variable, the given problem reduces to the form. So you see max z equal to this remains same minus x1 to then where slack variable, then these are 0 into, here you see 0 into x3, 0 into x4, 0 into x5, slack and surplus. Then this one will be minus m into x6 minus m into x7. Earlier we use here s1, s2, s3 like this. Then here you see total number of variable is here 7 and here number of equation is 3. So how many variable we consider 0? 4 variable is considered 0. Which 4 variable? Those do not get give us the identity matrix. So x1 0, x2 0, x3 0, x4 0. Then we get what? x5, x6, x7. Right? So this is the value. Then you put same as b for the basic variable. You see the table. So here and CB is the coefficient of the basic variable, CG is the coefficient of the objective function, and XB is the current basic feasible solution. Right? So next, Y1 indicates all the coefficient of X1, Y2 indicates all the coefficient of X2, Y3 indicates all the coefficient of X3, Y4 similarly X4, Y5 X5, and then A1 and A2 just indicate, these are the A1 indicates all the coefficient of X6 and A2 indicates all the coefficient of X7, because this is the artificial variable. Then you put the value, all this value, then you see here z equal to formula is CB into XB, so value is minus 60m. Delta J, first delta 1 will be 5m minus 1, second one is minus m, then minus m 0 0. So here you see m is large positive number, right? So here which one is positive? First column, 5m minus 1 is the positive value. So we find out the minimum ratio. Minimum ratio will be what? XB by incoming vector. Incoming vector is first y1. So you find out XB by incoming vector means 30 by 3. So this is 10. Then 30 by 2, this is 15. And 5 by 1 is 5. So 5 is the minimum. So our A6 will be the outgoing. So A6, this will be the outgoing vector. A1, A2. This is not A6. This is Y5. You see, this one will be Y5, not A6. You will correct this one. Y5. Y5 in basic variable A1, A2 and Y5. Right? So here you see Y5 is the outgoing and Y5 variable is replaced by Y1. Right? So then in the second table you see, in the second table what happened? This one will be A1 remains same, A2 and Y1. Y1 coefficient is minus 1. Then same as earlier, this will be new element equal to old element minus intersection of key row key column divided by the pivot element. Our pivot element is what? 1. So after calculating the second table, you will see you will get Z equal to 35m minus 5, and delta J value is 0 minus 6m minus m minus m minus 5m 0 0. M is large, right? Large positive number. So all delta J value is less than or equal to, right? So here no delta J greater than 0. So hence optimality condition is satisfied, and therefore this solution is optimal. And optimal solution is what? X1, X2. So X1 is 5, right? And X1, X2, then X3, X4, this value, right? So here you see X1 is what? X1 means Y1, corresponding to Y1. So X1 is 5, then X2 is absent 0, X3 is absent 0, X4 is 0, X5 is 0, and X6 indicates A1, so value is 15, and X7 indicates A2, value is 20, right? So hence here you see in the final simplex table, all delta J less than or equal to 0. But here you see M, we here cannot eliminate M from Z, right? So here artificial variable present in the basic solution. So here we write the artificial vector A1, A2 appear in the basis at the positive level, which immediately indicates the given problem has no feasible solution. So in BGAM method, what we know, if artificial variable is present in the basis, right, and then this gives us no feasible solution. When all delta J less than or equal to 0, an artificial variable present in the basis, then this gives us no feasible solution. So this is the problem of no feasible solution. Here calculation of the table is same as earlier. New table equal to, here you see new element equal to old element minus intersection of key row key column divided by pivot element. Then here you see one thing, remember M is the large positive number, right? Your exam sometime mentioned show that, but here what happened, not mentioned. This is the problem of no feasible solution, right? So just problem is given, solve the following linear programming problem. So if that type of problem is given, then after this you will write this problem has no feasible solution. Response your name.